Okay, so let's dive into this. Imagine you're looking way out there, 60 million light years away.
That's a long way.
Yeah, really far. To a galaxy, IC 758, it's an Ursa Major. You see these Hubble pictures, the ones you shared. It looks just, well, beautiful, doesn't it?
It really does. Very serene. You see these soft blue spiral arms kind of swirling around this hazy middle part. It looks peaceful.
Total cosmic calm, you'd think.
Exactly. It presents this like perfect picture, but like the material you send over shows that calm look. It's hiding something pretty dramatic.
A violent history.
Yeah, that's the paradox we're getting into based on your sources. Really fascinating stuff.
Because hidden in there, back in 1999, something huge happened. A star, a really massive one. Much bigger than our sun.
Oh yeah, way bigger.
It just exploded, end of its life.
Violently.
That's it. It wasn't just some little flash, it was a proper supernova. SN 1999 BG, they called it.
SN 1999 BG. Yeah. A single event, really brief in cosmic terms, but just unbelievably powerful, spectacular. When a star that massive dies, it doesn't fade away.
No quiet exit.
No way. It collapses, then bam, rebounds with this incredible force, sends shockwaves just tearing through the galaxy.
Wow.
And it throws all its stellar material, its guts, out into space.
Right. And the main point here, from the research you shared, isn't just looking back in 99, it's about now, decades later.
Exactly. What's left? What's the legacy?
Astronomers are using Hubble, its sharp vision, to look at the lingering effects, the aftermath of that explosion at IC 758. So this deep dive, it's really asking, what happens to a galaxy long after a massive star dies like that, after the supernova light itself is gone?
And that's such a fundamental question, isn't it? Because a supernova, it's not just an endpoint, it actively reshapes everything around it.
Also, the explosion itself.
Well, the explosion, yeah, and the shockwave it sends out, it doesn't just stay put, it slams into what we call the interstellar medium.
Ah, right, this sort of thin soup of gas and dust that's just between stars and the galaxy.
Exactly that, the cosmic soup. And when that shockwave hits this soup, well, that interaction is really the key to the whole aftermath story.
Okay.
Because it can do different things. It can hit, say, a diffuse cloud of gas and just pow, blast it apart.
Just disperse it.
Yes, spreads the gas out too thin. So gravity can't really grab hold anymore and pull it together to make new stars. So in some places, it actually stops star formation.
Okay, so the violence just kind of disrupts everything. That makes intuitive sense.
It does. But, and here's where it gets really interesting. The shockwave can also hit denser clouds.
Denser stuff.
Okay. And instead of just scattering it, it can actually squeeze it, compress it, like a giant cosmic fist clenching. And that sudden squeeze, that can push the gas and dust close enough together that gravity does take over. It can make parts of that cloud collapse.
And form new stars?
And actually trigger new star formation, kickstart it.
Whoa. So the same explosion, the same shockwave, it can shut down star birth here, but spark it over there.
Yes.
Just depending on what kind of gas cloud it runs into.
Precisely. It's this amazing duality. Destruction leading directly to creation happening right next to each other.
That's incredible. A cosmic cycle right there.
It really is. And it's not only the energy, the shockwaves punch. Remember the star itself when it exploded?
Yeah, it didn't just disappear.
Right. In its core, and especially during the explosion, it cooked up heavier elements. Things like, oxygen, silicon, iron, stuff essential for planets, for life.
All the heavier stuff.
And that gets blasted out too, mixed in with all that gas and dust.
So the star's material, its contribution, gets seeded into the galaxy.
Exactly. It becomes part of that interstellar medium, enriching it. So if that shockwave then compresses a cloud and triggers new stars.
Those new stars will contain those heavier elements from the dead star.
They're literally built from the ashes of the previous generation, material forged in that supernova.
So that incredible explosion back in 99 in IC 758, it wasn't just this isolated destructive event. It's a force that's still, decades on, shaping where and how new stars might form there.
And it's seeding those star nurseries with the elements needed for future solar systems, potentially.
It fundamentally sculpts the galaxy's next chapter. It changes the chemistry, the density,
Yeah.
everything for the next round of stars.
That's a great way to put it, sculpting the future.
Which, it always brings you back to this bigger thought when you explore things like this. If the stuff thrown out by dying stars becomes the raw material for new stars,
Yeah.
and those stars might form planets, maybe even life.
It makes you think, doesn't it?
It really does.
Yeah.
What does that tell you about where we come from? The actual atoms in your body, the iron in your blood,
Yeah.
Where did it originally get made?
In the heart of stars and in these violent creative explosions.
Exactly. It connects us, directly to these cosmic deaths and rebirths happening across the universe.
Yeah.
Even in a galaxy like IC 758, 60 million light years away, looking so peaceful, but actually teeming with this incredible cycle of creation and destruction, makes you look at those images a bit differently.
Absolutely. There's always more going on beneath the surface.